back to my life. Thank you for joining me now. Now we have a question here on circular motion to unravel. And what does the question says? Question says figure 6 shows a rotating spacecraft that is proposed to carry astronauts to Mars. Okay, and here is figure 6. It has this figure. This arrow is the radius, this is length, and this is the direction of rotation. And the question is, the spacecraft consists of two parts, A and B, like as we can see on the diagram, connected by a rigid cylindrical rod. Okay, so when the spacecraft is traveling, A and B rotate at a constant angular speed about their common center of mass, O. Alright, so now we have that L is the distance between the center of mass A and the center of mass B. So here is L, from here to here is L, so is the distance between the center of mass A and B. And then we were told that RA is the distance from O to the center of mass A. So where is RA? So is the distance from A to the center O. That's RA. So now the first question says, as the spacecraft rotates, a force that imitates the effect of gravity acts on an astronaut who is in contact with the floor. So you are asked to explain why. So now they said a force that imitates the effect of gravity acts on the astronaut who is in contact with the floor. Explain why. So now the force that actually acts on the astronaut is the centripetal force. You have to know that force. Centripetal force acts on the astronaut. Okay, who is in contact, who is in contact with the floor. It is an inward force. It is an inward force that keeps an object to move in a circular manner toward the center. Okay, so centripetal force is the inward force that makes the object to move in a circular manner and continuously in that regard. Now that was the first part of the question. Now the second part of the question says the force exerted on A and B by the connecting rod has the same magnitude. Okay, the force has the same magnitude. So MA is the mass of A, MB is the mass of B. We are asked to show by considering the centripetal forces acting on A and B that RA is given by this. So how do we show that RA is equal to this? So we should be able to show that. Okay, I want to draw my margin so that we'll have enough space in order not to exhaust the whole space. Now it's because of the fact that the forces exerted on A and B by the connecting rod have the same magnitude, meaning that the centripetal force of A is equal to the centripetal force for B. So, and we know that the formula for centripetal force is the product of mass, angular velocity square, and the radius. So centripetal force for A will be mass of A multiplied by the square of the angular velocity of A multiplied by the radius of A equal to mass of B multiplied by the square of the angular velocity of B and radius of B. Okay, so the magnitude, they both rotate, so the magnitude of the angular velocity will generally be equal, so the angular velocity will cancel out. So therefore we have that mass of A multiplied by the radius of A, okay, equal to the mass of B multiplied by the radius of B. Now, but meanwhile, from the diagram, we know the radius of A and B. Okay, let's see from the diagram. From the center to the astronaut to A, that is the radius of A. Then to get the radius of B is going to be the total length minus the radius of A. So we get the radius of B. So which means that our MA equal to RA, MARA equal to MB into the bracket R, that is L minus RA, which means that the radius of B is equal to L minus RA. So we substituted that in here. Okay, now we continue from here. So on exposing the bracket, remove the bracket, we have our MARA equal to MB multiplied by L, that is MBL, minus MB RA. So we remove the bracket here. Now we need to collect like terms, so we let the MBRAs come here. Okay, since we have RA here, we have RA here, so we have our MA RA plus MB RA equal to MBL. All right, so now we can actually factorize to make our A the subject. So RA into the bracket of MA plus MB, then you close the bracket, equal to MBL. Okay, so we can now divide both sides by MA plus MB, MA plus MB, this side also MA plus MB. So this can easily cancel out that. So we are left with RA equal to MBL minus, all over MA plus MB. Okay, that has been shown. So we have this, which is equal to this. Done. Now we quickly move to the next question. And what does it say? It says in this spacecraft, mass of A is less than mass of B. Let's see. says mass of A is less than the mass of B. Alright, seen. Then deduce whether the center of mass of A or the center of mass of B rotates at the greater speed. Excuse me. So we are asked to deduce whether the center of mass of A or the center of the mass of B rotate at a constant or mean at a linear greater speed. All right. Now the point is that both have the same angular speed. A and B, they have the same angular speed because they are both rotating. They will have the same angular speed, and we have actually seen that in this equation where we cancel out the angular speed in this equation. Now, but the linear velocity of A will be greater than the linear velocity of B. Why? From this relation that say V, the linear speed is equal to angular speed multiplied by the radius, which means that the increase in the linear speed will be equivalent to the increase in the radius. Okay, so it will be equivalent with the increase in the length of the radius. So at constant angular speed, so we have that V varies directly as the angular speed. Now when we look at the radius of A, which is RA, is longer than that of B. Okay, so how do we interpret that? How do we place the answer for that? So you write that both A and B have the same angular speed. However, the linear speed of A is greater than that of B from the equation V is equal to omega R. So therefore the greater the radius, the greater the linear speed at constant angular speed. Okay, so that's done. Now we were told here that the astronauts live in A and the cargo is stored in B. When loaded, mass of A is 1.32 times 10 to the power of 6 kilogram, and mass of B is 3.30 multiplied by 10 to the power of, we are given the spacecraft imitates the gravity of mass of G equals 3.7 times 10 raised to power minus 2. That is the, so this the picture. The figure 7 shows the stress strain curve for the metal used for rigid rod. So we have the graph of stress in gigapascal and the strain. Okay, so we are asked to suggest a suitable diameter to justify your answer. Okay, now the mass of A has been given to be 1.32 times 10 to the power of 6. 1.32 times 10 to the power of 6 kilogram, and gravity is 3.7 in the mass. Gravity has been given to be 3.7 meter per second square, or Newton per kilogram, but we are given meter per second square. Okay, so we can get the force of the object, since we know the mass, by using the relationship mg, that is 1.32 times 10 to the power of 6 multiplied by 3.7. Okay, so on calculating that, we have that 1.32 multiplied by 3.7 1.32 multiplied by 3.7 times 10 to the power of 6. So which is equal to 4.88 times 10 to the power of 6 Newton. Now, we know that tensile stress is equal to force over area. Okay, so therefore area will be equal to force. Area will be equal to stress over force over stress, rather. Apologies. Stress over force over stress. Okay, now we can quickly calculate the area from diameter. So area in terms of diameter is 4 pi that is pi d square over 4. Okay, pi d square over 4. So which means that pi d square is equal to 4a. Then divide both sides by pi. Okay, so this cancel that. Then d will be equal to the square root of 4a over pi. All right, so now the question is, do we have the area? Then you can input your area, which is force over stress. From here, we have that area is equal to force over stress. Okay, so we've gotten force to be equal to 4.88 times 10 to the power of 6. Then the stress, we can get that easily from the diagram. Okay, the stress won't be in 3.0, no, but meanwhile this is where we trace. I will trace it down here. That will be 3.05. Okay, 3.05 times 10 to the power of 9, because it's actually in gigapascal. Okay, times 10 to the power of 9. So we can now say, therefore, that our area is 4.88 divided by 3.05 times 10 to the power of 6 minus 9 indices. So 4.88 divided by 3.05, that gives 1.6. So the area is 1.6 times 10 to the power of -3 meters square. So we can now substitute the area, which is equal to this, in this equation for us to get the diameter. So diameter will be equal to the square root of 4 multiplied by the area, 4 multiplied by 1.6 times 10 to the power of minus 3 divided by pi. Pi is 3.14. Alright, so this will therefore be the same as saying 4 times 1.6 divided by 3.14 multiplied by 1000. I brought down this 3 to the power of negative 3. So that will therefore be equal to the square root of 4 multiplied by 1.6, which is 6.4, divided by 3.14 multiplied by 1000, that is 3140. So we can now divide 6.4 divided by 3140. So diameter will be equal to 0.00204, and that will be, we have to find the square root of that. Okay, so the square root of that will therefore be that is 0.045. So the diameter is 0.045, which is the same thing as 4.5 times 10 to the power of minus 2 meters. So now